Unit 2, Lesson 14. We'll say math is good. Solving systems by elimination, part 1. We're starting off with these hanger diagrams here in the book. It asks us, what do we notice and wonder? I'll let you pause the video and do your own notices and wonder. But one of the things I see is that 2 circles is the same thing as 1 square. So if I come over here and I look for that, I can see 2 circles right here. That could be 1 square. These 2 circles could be considered 1 square because they're perfectly balanced. Also, I have a pentagon here that is a circle and a triangle. So like this pentagon here could be considered a circle and a triangle. Now, if I rewrote this over here, this side all becomes, these 2 guys turn into a square, then I have a circle and a triangle, and that's balanced out with a square and a circle and a triangle. So by combining what we know is balanced on this side, we could create something else that's balanced on this side. Or, this is actually what they're looking for in this lesson, I could take this whole hanger and I could just combine it with this hanger and I'll end up with this hanger. So if I just take my 2 circles here on the left, 2 circles on the left, and then I take another circle and a triangle, I have a circle and a triangle, I end up with 1, 2, 3. That's my left side, and then my right side would be balanced with 1 square and a pentagon. Now, that's the idea of this lesson. Elimination works because when you take 2 balanced things and you combine them together, you will get another balanced thing. So it should actually work out that way. I guess I have to keep looking on the screen and see if I'm on the screen here. All right, we are on 14.2. Diego is solving the system of equations. Previously, we would use our substitution steps. We would look for the easiest variable. None of these look very easy. I would probably go for the x on this term here. Divide by 4 is not too bad for that. Now, however, Diego doesn't seem to do it this way. Diego is doing his work here. So he is just slamming these 2 equations together like we did in the intro. He's adding straight down. So 4x, negative 4x, that's a 0. 3 and 5, that's an 8. 10 and 6, that's a 16. And then he's going to divide by 8, and he's left with his answer right there. He takes this answer and he is going to plug that into the y right here. So that becomes this term. 3 times 2 is 6. He moves the 6 over by doing a negative 6, negative 6. This crosses out, gives him 4x equals 4. He divides by 4, divides by 4. And then he gets x is 1. Now, Mr. Sinclair doesn't think this is done here. I would like one final step where we write this as an ordered pair. So it would be an x comma y, like so. And so then I would have a 1 comma 2. Make sense of Diego's work and discuss with partner. What did Diego do to solve this system? He adds both equations together, and the x term crosses out. Now, that's our vocab for today. Crosses out is eliminates. That's why we are calling this solving systems by elimination. Is the pair of x and y values that Diego found actually a solution to the system? How do you know? We could do several things. Thing number 1, we could graph it. And actually, I think I have a graph set up right here. And I have these 2 equations graphed. So the red one here is the 4x, 3y, and the blue one is the 4 and 5. And they go and they touch here at this point. And so that is one of the solutions. So they touch where they graph. So if I wanted to say that, hey, they both touch, I have a graph coming down like this, I have a graph coming up like this, and they touch here at 1, 2. That's one thing I could do. I could also plug them in. Plug and check. Okay, so we could plug them into the first one. 4 plus 3y equals 10. And I can plug them into the second one. Negative 4 x and 5y equals 6. So I could plug in my 1 and my 2, my 1 and my 2, and I believe these will work out. Let's check. 4 times 1 is 4, 3 times 2 is 6, and that would be 10 equals 10. That is checking out. That works. This will be negative 4, positive 10. This is 6. That also works. That checks out. All right. Now let's keep going. Does Diego's method work for solving these systems? Let's see. I'm going to move this up a little bit for us. There we go. Okay, so can I add straight down? Will this work? Let's try those out. So if I add these down, this is an invisible 1, an invisible 1 right there. So I would get 3x. And then these guys cross out, so I get plus 0 equals 15. That seems like it works nicely. I have that term eliminate. This term eliminates. This is looking nice. So then I have 3x equals 15. And I could just divide both sides by 3. Divide by 3. And I will get x equals 5. Now I'm not quite done. I need to plug back in to find y. I'll let you guys do that yourselves. I don't want to take all your fun away from you. All right, let's try this one. Let's add this one straight down. I have 8x, I get 16x, and I have 11 and 1. That's going to give me 12y. And then I have 37 and 7, which I'm not the best with addition. Oh, look, I have it already set up here. I have 44 right there. So I have 44. Okay, now this did not work. Didn't work. What could we do to fix this? One of the things we could do to fix this is I noticed that these guys would eliminate if this bottom one was negative. So if I could actually take this bottom equation, I would want to convert it so that it's a negative version of itself. And I can do that by basically distributing a negative 1. So I'm going to take an 8x, 1y equals 7, and I'm actually going to distribute a negative 1 to every term. Basically, this will work if instead of adding, I'm going to subtract. Now, it'll get a little more complicated later on, but let's change all our signs here. 8x, negative y equals 7. And now I could take this one without changing it at all, and they will cross out. I have 8x, y, and 37. This should be negative there. And then these guys will cross out. I'll get 10y equals 30. And this will, now I have an elimination. This did work. And I'll let you figure out what my y is. Y equals question mark. And then you're going to go ahead and plug back in to find your x. All right, let's see what we have coming up next. We have 14.3 3. Here are the 3 systems that you saw earlier. So these are our 3 systems. And it says for each system, use graphing technology to graph the original 2 equations of the system, then identify the coordinates of the solution. Okay, so I'll go ahead and we know the first one here. Let's pull this up. So I already know my solution is 1, 2. That's my answer here. So I put that down here. I know my answer is going to be 1, 2. Let's come back to this and put the next one in. So I'm going to have a 2x. Hold on, move my keyboard a little bit. 2x plus y equals 4. And I have, ooh, those are capitals. They don't like capitals. I have caps lock. Y, there is my new line. And then my other one is going to be x minus y equals 11. Let's get rid of these. Clearly, this point no longer the solution. My solution is down here. Okay, so my solution is down here. I'll put that on. I'll turn this off. So I know this is the solution for the second one. So let's come in here. I know that my answer is 5, negative 6. Okay, I'll let you go ahead graph this one and figure out what your answer is yourself. I think I have the answer key pulled up here. I have these 3 systems here. This last one, it looks like it's going to have a half as its solution. So I know this one's going to be 1/2, 3. I would put it in as a 0.5, 3. Okay. Now, use graphing technology to graph the original 2 equations in the system, then identify coordinates of the solution. Done. Find the sum or difference of the 2 original equations that would enable the systems to be solved. Okay, so let's go ahead and do that. Why don't you sum these down yourself? And then remember, whoops, let's go ahead and add these down ourselves. Now this one, you're going to actually have to subtract like we did before. Now, once you do that, I want you to graph those new equations you have. So I'll do the first one for you. Here I have 4x plus 3y, and I'm going to add it down. So these terms are going to cross out, and I'm going to get 8y equals 16. And we're going to go ahead and graph that on that same system. Actually, I haven't done this. Let's see if this works. Okay. So we have to change this back to that equation that we had. So 4, I wonder if Control Z works. Yes, it does. So we're going back, 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 back. Okay, we're back to here. I'm going to put in this new equation. 8y equals 16. Huh. I got this flat line coming through here. This flat line is a y equals 2 line, which makes sense because when I solve this term here, I would get y equals 2. That's interesting to see. And it also crosses at that same point. That's really interesting. Because if I finish this up and I go ahead, I divide by 8, I'm going to get y equals 2. And that is that flat line going through y equals 2. Honestly, that's what we saw there. That is this green line here, that flat green line going through the 2. I wonder if I can zoom in on this. There we go, make it a little bigger for you. Okay. What do you notice about the graph of the new third equation for each system? So you're going to have to do the work here, find me my third equation, and go and graph it. find me my third equation here, graph it. I'm going to have a sneaking suspicion that all of those are going to go through the points. So all the combined equations still touch each other at the solution. And really that happens because they are equivalent. Equivalent, I don't know how to spell, equivalent equations share the same solution. Okay, let's see what we have coming up next. We have an Are You Ready for More? I'm going to leave this one, and then we have our summary. Our summary is talking about elimination. Another way to solve a system's equation algebraically is by elimination. Just like in substitution, the idea is to eliminate one variable. So this one is set up here so that this variable will automatically eliminate itself. All right, let's try our practice problems, and hopefully that was helpful. I guess we could also say math is good all the time.